Hello there, and welcome to this presentation by Team ColiPrev. On behalf of myself, Julius, and my teammates Natalie and Aniket, it's a pleasure to have you here. Over the past day or so, our team has worked on developing an image recognition and simulation software to predict and help avert satellite and space debris collisions. To start, let's talk about the problem a little more in detail. With the increasing amount of both space debris and satellites in orbit, it's critical that we're both able to predict and prevent these collisions that can cost both millions or billions of dollars, disrupt critical technologies, and cause danger to civilians back on Earth. Now, let's talk a little bit more about how we plan to solve this problem. So let's say that we have the Earth, and around the Earth we have a satellite floating around, as well as a piece of space debris. So here we have our satellite, and now we're going to have our piece of space debris, and now we know that that piece of space debris was in the approximate vicinity of the satellite at this given point in time. Now, if we use image recognition to tell that that piece of space debris was actually in another point in orbit at another satellite, we now can start to illustrate sort of a path of orbit for that piece of space debris. So here we have a rough path, and now we can illustrate actually a pretty accurate orbital equation for the space debris. Here we go. So the first piece of software that we came up with to solve this really is a piece of machine learning software that uses image recognition to detect asteroids and space debris in the vicinity of camera fields from a hypothetical satellite. And we did this by training the machine learning algorithm with a bunch of images of asteroids and of space debris. And as you can see, sort of after installing a bunch of packages and training the model, we were able to come up with an actual output from an image. And so we're going to show you that here. So here we actually have a sample asteroid / space debris, and we're able to tell both the coordinates and the location of that in relation to the satellite. So the next piece of software that we came up with is a piece of simulation software where you're able to input information about the orbit of both the satellite and of the piece of space debris, and it's going to run their positions for the next year and determine if there is a significant risk of collision. And on the right, you do see here an actual visual simulation of that using Python. So in this case, there would be no significant risk of collision. And sometimes for efficiency purposes, we built in a system for the algorithm to be able to tell if there is no risk of collision at all right away when you put it in. So for example, if you have a satellite at 100,000 feet and a piece of space debris at 200,000, the risk of collision is actually very, very minimal just due to the difference in orbital radius. And finally, here we have a scenario where it will actually output that there is a risk of collision. We're going to put in the same orbital period, similar locations, and once we run it, it's going to show us that there is indeed a high risk of collision at the certain point, which it's going to output right there. Now, this brings us to the end of our presentation. We'd like to thank you very much for taking the time to join us today. We do encourage you to check out our dev post and our GitHub for more details, and to, of course, reach out with any questions. Have a great one.